Math 3, graphing rational functions. Okay, so we're supposed to identify the holes, the vertical asymptotes, horizontal asymptotes, and the X Intercepts, and then sketch the graph. Okay, so now, in order to be able to do this, we need to understand how to find each one. Okay, now, the first thing that we need to look at is, and this frame you can download on the website if you don't have it, okay, is let's look at the horizontal asymptote. Okay, the horizontal asymptote here is the easiest to find. So you take a look at the highest degree of the numerator and the denominator. So going back to our problem, the highest degree on each of these is 3. Okay, oops, too far. So then the numerator we'll call m, denominator n. So if the degree m is less than n, so the top is bigger than the bottom, then your asymptote is at the x-axis, y equals 0. Okay, here's an example. X to the first, x to the second. Smaller on top than on the bottom, y equals 0 is the asymptote. Okay, now if they're the same, then you take the leading coefficient and that becomes your asymptote. So that's our situation right there. So if we look at this one, our coefficients would be 1 over 1. So we have an asymptote, a horizontal asymptote, at y equals 1. So at y equals 1, here's our asymptote. Okay? Now, if you look at this situation, we have the top bigger than the bottom. See, do we have one where it's the there's top bigger than the bottom. That's this one. If we have that, it's a slant asymptote, and you have to use long division to find it. Okay, so those ones are more complex. Well, it doesn't look like we have one where the top is smaller than the bottom. That's unfortunate. Anyway, so there's our asymptote. Okay, that's the first step. Okay, is finding the horizontal asymptotes. The second one is to find the vertical asymptotes, including holes and the X-intercepts. We're going to have to simplify. Okay, we're going to have to take our graph and we're going to try to simplify things. Okay, so first thing I should be able to notice if I want to simplify this, they all have an x, right? So I can pull an x out of every single one of them. So if I do that, I get x squared minus 6x plus 8 on the top. On the bottom, I get x times x squared minus 2x minus 8. So now we factor these. Okay, factors of 8 that add up to negative 6, negative 2 and negative 4. So I get x times x minus 4 times x minus 2. Okay, there's my top. Now on the bottom, factors of negative 8 that give you negative 2. A negative 4 and a positive 2. So I have x times x minus 4 times x plus 2. Okay? So, now what we need to do, okay, is look for stuff that can eliminate. We should notice that the x's and x minus 4 can be eliminated, both of them, okay? So, if you can eliminate it, it turns it into a hole, okay? So we're going to have two holes on our graph. A hole at x equals 0, because you set it equal to 0, and a hole at x minus 4 equals 0, because those both can be eliminated, okay? So I have holes at, so plus 4, so x equals 4. So we'd have 0 something and 4 something. Okay, those just gives us the x values. Okay, to figure out the y values, I've got to do one more thing. Now, what's left over, we have x minus 2 over x plus 2. Okay, so what we need to find now are the vertical asymptotes. So to find the vertical asymptote, you take the bottom number and you set it equal to 0. So I go x plus 2 equals 0, which would give me negative 2. Okay, so that means I have a vertical asymptote where x is equal to negative 2. So at negative 2, here's a vertical asymptote. Okay. Now, to find the x-intercept, we take the top number, okay, you take the numerator once it's been simplified, set that equal to 0, and that's where your x-intercept is. So x minus 2 would be plus 2, we get x equals positive 2, so I have an x-intercept at 2, 0. Okay. Now we need to find the y values for the holes. So you take this piece and we plug our numbers in. So 0 for x, 0 for the other x, negative 2 over positive 2 becomes negative 1. So at 0, it's at negative 1. So right here at 0, negative 1, there's a hole. Then we do it with 4. So I go 4 minus 2, 4 plus 2. So 4 minus 2 would be a positive 2. 4 plus 2 would be a 6. 2 over 6 is 1/3. So at 4, we go up to 1/3, right about there would be a hole. Okay? Now we can piece it together. So because of the asymptote, my end behavior is going to always be close to that asymptote. It'll go through the hole, through the x-intercept, through the hole, and then dive down to keep going down. Then we go down and jump back up here, right? So we're always going off to the right, down. The holes in the x-intercept tell us that this side we're going down. And then this one is just going to look like that. We don't really have any other numbers to help us, so we just kind of draw it like that. Because the parent function here, the parent function is 1 over x, and that has a vertical asymptote right here, a horizontal asymptote right here. Okay, and if I have positive numbers, they give me positive numbers, so it looks like this. If I have a negative number, it gives me a negative number, and it looks like that. Yeah. Okay. So that's how we do all the work. Okay. So once again, okay, horizontal asymptote, you look at the highest degree. If the number on top is smaller than the degree on the bottom, it's the x-axis. If the top number is bigger than the bottom, it's a slant, and we'll show you how to do that one. If they're equal, you take the leading coefficient, that becomes your horizontal asymptote. To find the rest, you simplify, you take your equation, you simplify it on what can be eliminated. Okay? Anything that can be eliminated turns into a hole. You set it equal to 0, solve for that, use that, plug it back into the equation, find the y value for it. Okay? Then you take the numerator, okay, or the denominator you set equal to 0, that tells you your vertical asymptote. Take the numerator, set it equal to 0, that tells you your x-intercept. Okay? So here's another example. If we were to take this, okay, same, so my horizontal asymptote becomes 2 over 1. Okay, right here shows you. Okay, so y equals 2, horizontal. Then I simplify these. Simplifying these, I come up with x minus 3 times x plus 4, x plus 2 times x plus 4. X plus 4s cancel out, so that's going to be a hole. X plus 4 equals 0, hole at negative 4. Okay, I'm left over with this piece, so I plug in negative 4 to x. We get negative 7 over negative 2, so 3.5. So the point negative 4, 3.5 gives me a hole, which I make a hollow circle. Okay, take the numerator, set it equal to 0. That tells us our x-intercept. Take the denominator, set it equal to 0. That tells us where our vertical asymptote is, and then we just draw our graph. Okay? Alrighty. And like I said, the parent graph looks like this, okay, with the horizontal and vertical asymptotes there. You may need to be able can use your factoring skills to help you with some of this. Alright, so let's bust these out now. Okay, so higher on the top than on the bottom. Okay, that sucks. But let's simplify. We would get x times x minus 2. And then this one we can divide by 4. So we'd have 4 times x minus 4. Okay, so didn't help us a whole lot, did it? So nothing's going to cancel there. Okay, so we can find our horizontal asymptote by doing long division. Okay, so what that means is I'm going to have to take this and divide it into this. Okay. Alright, now, synthetic division we could try to use, but it doesn't work as well because of this. We'd have to divide by 4, but there's more to it. So this is just easier. So how do I get 4x to become x squared? Well, I have to get rid of the fourth by times it by 1/4 and by an x. So 1/4 x times 4x gives me x squared. 1/4 times 16 gives me 4, negative 4, and then x. So I change the sign and add them. It becomes 0, negative 2 plus 4 would give me positive 2x plus 0. Okay. Then I would have to multiply by 1/8. No, by 1/2. So 1/2 times 4x would give me 2x. 1/2 times negative 16 would give me negative 8. And we end up with, change the sign and add those, we end up giving us 0 and we get 8. Okay, so we have a remainder of 8. So plus 8 over 4x minus 16. Okay, but we don't pay attention to that remainder. We just pay attention to that linear part. That's going to be our horizontal asymptote. So I go up to 1/2 for my y-intercept, about right there. My slope is 1 over 4, so I'm going up 1 over 4. Up 1 over 4. Or down 1 to the left 4. Down 1 to the left 4. So this right here is my slanted, oh, we're doing this one, by the way. This is my slanted asymptote. Okay. Now to find the vertical asymptote, we take the bottom, set it equal to 0. So 4x minus 16 equals 0. Add 16. 4x equals 16, divide by 4, and we get x equals 4. So at positive 4, we have our horizontal asymptote, or vertical. So my slant asymptote is 1/4 x plus 1/2. Okay. My vertical asymptote is x equals 4. Okay. Now, I don't have any holes because nothing eliminated. So I take the top here, and I take each one of these separately, and that'll give us our x-intercepts, because we can have more than one. So I have an x-intercept at 0. Okay. That wasn't a very good dot. I also have an x-intercept at x minus 2 equals 0. So we get x equals positive 2. Okay. So what that means is my graph is going to start back here to reach the x-intercept. It'll climb a bit and then come down. And then the other side will just shoot like that. Okay. And there we go with that one. Okay, number 3, same idea. I've got that slant asymptote. Okay, so once again I'm going to have to use long division. So negative 2x minus 4 divided into x squared plus x minus 12. So I'm going to have to multiply by a negative 1/2 x, because that will give me x, positive x squared. Negative 1/2 times 4 is a positive 2x. Change the sign and then add them. That becomes 0, 1 minus 2 becomes a negative x minus 12. Bring that down. Then, to get a negative 2x become a negative x, I'm just going to have to times by a positive 1/2. 1/2 times negative 2x would be a positive x, or a negative x. 1/2 times negative 4 would be a negative 2. Change the sign and then add them. Be 0, and I'm left over with negative 10. But we don't pay attention to the remainder. We just use that piece. Okay? So I go up to 1/2, and I'm going down 1 every time I go to the right 2. So some linear graphing going on here. So there's my slant asymptote. Okay. Instead of horizontal, it's slant. Now we simplify. Factors of negative 12 that would add up to positive 1. 3 and 4, with 3 being negative. So the top is really x minus 3 times x plus 4. The bottom, I can pull out a negative 2, and that would give me x plus 2. So nothing can be eliminated there. Okay, so I take the bottom, x plus 2, because that's, I would just divide out, equals 0. This will give me my vertical asymptote, negative 2. Okay, so vertical asymptote right there, horizontal asymptote right there. Did anything cancel? No, so no holes. Holes, none, and sometimes you have them, sometimes you don't. Okay, to get my X-Intercepts, I take these two guys, because I know it's either going to look something like this and this, or this and this. Okay, those are really my only two possibilities. You're never going to have this and this unless you have more than one vertical asymptote. Okay, so we've got x minus 3 equals 0 and x plus 4 equals 0 for my X-Intercepts. So add 3, so we have x equals 3, subtract 4, and x equals negative 4. So those are my X-Intercepts. So positive 3 right here, and at negative 4. Okay, so I'm going to follow that, hit through my X-Intercept, go up like that, then start down here, hit through my X-Intercept, and go like that. And there's my graph. Alright, now number 4, this one's a little easier because now we have the same, so when they have the same powers, we take their coefficients 1 over 1, which is just 1, so y equals 1 is our horizontal asymptote. Much easier, right? Okay. Then we take the bottom, because nothing canceled out, so holes there are none. So I go x plus 1 equals 0. So the bottom, negative 1, x equals negative 1, that's my vertical asymptote. Denominator gives me my vertical asymptote. Okay. Then X-Intercepts. Take the top, x plus 4. Set it equal to 0. So x equals negative 4 is my X-Intercept. Okay. So that tells me which side it's going to be on. So I know now it's going to start right out here, come hit through there, come down here, and then it'll keep going and come down here, like that. Alright, let's see if we can finish these up. Now, I would like to show you, but that won't work. Maybe we'll have to do one of those in class. One where it looks like this, where just your y equals 0 is the asymptote, but that's alright. So I've got the same, so a negative 1 over 1, so my horizontal asymptote would be negative 1 over 1, or just y equals negative 1. Okay, if I look at number 6, same idea, right? 2 over 2, so 1 and 1, so my horizontal asymptote on number 6 is y equals positive 1. If I look at 7, 3 and 3, 2 over 1, y equals 2. It's my horizontal asymptote, so y equals 2. And then I've got 1 over negative 1, So once again, on 8, my horizontal asymptote is going to be y equals -1. Okay? Then what I have to do is I have to simplify to find the rest, right? So we can pull out a -1 first of all. It'll give me x squared plus 7x plus 12. Factors of 12 that would add up to 7, 3 and 4. So really that's going to be x plus 3 times x plus 4. Okay, on the bottom, factors of 3 that add up to 4, 3 and 1. So I get an x plus 3 and an x plus 1. Okay. Now, we don't really think of that -1 anymore. We don't really need it. Okay, so now we can cancel something out. So I've got a whole, right? So my whole is going to be at x plus 3 equals 0 would give me x equals -3. Then to find the y value, I put x into these, -3 into these x's. So I get -3 plus 4 over -3 plus 1, which would give me a +1 over a -2, so -1/2. So at -3, -1/2, I've got a whole right there. Okay, that purple one represents a whole. I just couldn't do it very well. Now for my x-intercept, we take the numerator, right? X plus 4, set it equal to 0, which hopefully we can see that that's going to be a -4, right? So at -4, we have our x-intercept. Okay. Alright, then we would take our denominator for our vertical asymptote. It's going to be x equals something. So x plus 1 equals 0. Subtract 1. We get x equals -1. So -1, we have a vertical asymptote there. Now, I'm not so sure that we did our whole exactly correct. Okay? Just because that's not looking right to me. I know what we forgot. That -1 did play into it. That should have been a -1. So -1 over -2 would give us a +1/2. Okay, so this would actually, x-intercept of -4, whole at -3 1/2. So that would make sense. So my graph goes here, then up, then we just draw the other piece like that. And we're done with that one. Okay, so now we already know the horizontal asymptote of number 6, because it had the same. So we simplify. Okay, factors of -2 that would be -1. How about 2 and 1, with 2 being negative? So I'd have x minus 2 times x plus 1 over, I pull an x out of that, I get x times x minus 2. X minus 2's cancel, so set it equal to 0, add 2. We get x equals +2, so we have a whole at +2. Take the leftover piece, x plus 1 over x. Put the 2 in, 2 plus 1 over 2. That would be 3 over 2, which is 1.5. So 1.5. So at 2 and 1.5, we have a whole right there. Okay, take the numerator for our x-intercept. Okay, x plus 1 equals 0, subtract 1, so at -1, we have an x-intercept. Then for our vertical asymptote, take the bottom, x equals 0, so x equals 0, so it would be at the y-axis. Okay, so that whole tells us that we're going to have a graph up here, the x-intercept down there. So then I just do my best following the end behavior and draw. It may not look exactly, because I can graph these on Desmos or a graphing calculator to double check, but it's not, we may not be exactly right, but we'll be close enough. Alright, number 7, we also know our horizontal asymptote. So we go, we simplify, don't we? Okay, So I can pull an x out of those and an x out of those. So I'm going to get 2, oh wait, and I can pull a 2, can't I? So 2x times x squared minus 5x plus 4 over, pull out an x times x squared minus 9. Okay, two things to notice here. Difference of squares. 9 is like 3 squared. So that would actually, the bottom would be x times x plus 3 times x minus 3, because that's what we do on a difference of squares. The top, factors of 4, that would be negative 5, negative 4, and negative 1. So I get 2x times x minus 4 times x minus 1. Okay. Now notice the only thing that eliminates is x's, so we have a whole at x equals 0. So 0, comma, then we find the y value, so getting rid of those, we would put 0 in for each of these x's. 0 minus 4 is negative 4 times 2 times negative 1, so that would be positive 8, over 0 plus 3, 0 minus 3, 3 over times negative 3 would be negative 9, so negative 8 over 9, which is almost negative 1. So a whole would be like 0, 8 over 9, negative. So it'd be like right there. Okay. Now we've got 2 vertical asymptotes. Okay. If we solve this for 0, we'd subtract 3, we'd add 3, so x equals positive 3 and x equals negative 3. So positive 3 we have an asymptote, at negative 3 we have an asymptote, and there's some weird stuff that happens in the middle. Asymptotes are more the end behavior, so we kind of in between 2 vertical, the horizontal kind of disappears. It's kind of weird, but it does that. Okay, then we're solving for x-intercepts, so x minus 4, so we'd have an x-intercept at positive 4 and positive 1. So positive 4 and a positive 1. So here's how this one's going to go. Because of this x-intercept, we're going to start like this. Okay. Okay, now, because we went down on the right of this, we're coming down to the left, but we have to get to that x-intercept in that hole, so it's going to kind of jog over and then jump down. Like I said, that horizontal asymptote almost disappears when you're going like this. Then it'll come back up here and go out to the end behavior. So that one's kind of wonky looking, but that's where you end up with it. Okay, let's see if we can bust out this last one. So I can pull out a negative here and have negative 1 times x squared plus x minus 6. Okay, we've got the horizontal asymptote, so let's factor. Negative 12, that'll positive 4. Negative 3 times 4, so I get x minus 3 times x plus 4 over negative 1 times factors of negative 6 or positive x, x plus 3, and x minus 2. We can't get rid of any, so we have no holes. Okay, so vertical asymptotes, take the denominators. So x plus 3 equals 0 would give us x equals negative 3. X minus 2 equals 0 would give us x equals 2. So positive 2 we have an asymptote. Negative 3 we have an asymptote. So we've got a double asymptote. So that vertical asymptote or horizontal may affect it, may not. Take the tops for our x-intercept. We're almost out of time. X minus 3 equals 0 would give us x equals 3. So positive 3 we have a x-intercept. X plus 4 would give us a negative 4, right? So at negative 4 we also have an x-intercept. So that tells me my graph is going to start off to the left, hit that x-intercept and go up. Then it's going to come down, but on the right side it's going to have to come down and hit that x-intercept and go like this. So that means at some point this is going to dive down and then back up. We didn't have an x-intercept, so it's going to go back up before we hit that x-intercept. Okay? And there's our graph. So it takes a little skill to know exactly how to graph them, but you can find out the other pieces. use a graphing calculator, use Desmos to double check your answers, and there's how we graph some rationals by hand. We'll do the calculator stuff in class.